Okay, so we're in another series of questions, and let me see. There's 5 questions. Looking around, for I would say low-hanging fruit. Number one doesn't look bad. Number two looks a little tedious, but it doesn't look that bad. Number three doesn't look that bad, and number five doesn't look that bad. I always say word problems for a lot of students are really difficult to deal with. All right, I'm going to attack number three first. All right. So number three would say write a polynomial of least degree with rational coefficients which have x equals 5, the root of the quantity 5 plus root 7 as one of its zeros. Let me write this down then. So x is one of its zeros, so it means x equals, and this would be root 5 plus root 7. Well, what I'm going to do is, if it's a root, I want to get rid of the radical, and I'm going to square both sides. And what do you get? X squared equals 5 plus root 7. Well, that was pretty easy. Then I'm going to do x squared minus 5 equals root 7. Now, root 7 is still an irrational number, and I got to get rid of that. So I'm going to square both sides now. And what do you get? You get x4 minus 10x plus 25 equals 7. And I think I have it now. x4 minus 10x plus 18 equals 0. Let me make sure I've answered the question. Write a polynomial of least degree with rational coefficients. I've done that, which has a root. That's one of here. Oh, I didn't see that one, but they said find all the roots now. All right, let's go to town. Let's find all the roots. That might be tough though. Fourth degree polynomial, but I do know one of its roots. And what I'm going to look at is I'll look at it, and I'm going to make a substitution here. I'm going to let u equal. No, that's not going to help me either. Oh, you know what? I made a mistake over here. I just noticed it. Now it's going to help me. U is equal to x squared. So what do you get? You would get u squared minus 10u plus 18 equals 0. And this is not going to factor over the integers because, 18 would be, 3 and 6 or 2 and 9 or 18 and 1. That's just not going to work it out. So u is going to be equal to, let's see, the opposite of b, which is 10, plus or minus, let's see, b squared, which is 100, minus 4 times a, which is 1, times 18. I'll clean this up in a second. Over 2, u is equal 10 plus or minus, well, 4 times 18 is 40 and 32, 72, so 28. I want to clean this up. And what are you going to get? You're going to get u is equal to 5 plus or minus. You may wonder why I'm saying 5 because 2 goes into 10 5 times. Now the root of 28 is 4 times 7, which is 2 root 7s. So what do I give there? I get plus or minus root 7. All right? And that's what u is equal to. But I want to know what x is equal to. And I'll write this down for you. X squared is equal to 5 plus root 7, or x squared is equal to 5 minus root 7. And I'm going to use the square root rule now. What do you get? X equals plus or minus 5 plus root 7. Now that's, I don't have to think too much about that. The other one you have to think about, but the square root of 7 is nowhere near 5, so it's a positive number. I'm not looking at complex numbers now. And what do you get? Plus or minus the root of 5 minus root 7. Let's look at the key, see how we did. And let's see. I think I got this, and I think I got that. Let me just make sure of that. Oops, what am I doing here? Yeah, we did. We got it. We got the same numbers. All right, this is good. All right, so I'm going to say 3 down. I'm sorry, number 3 down, 4 more to go. All right, as always, you know what I'm going to do? I'm going to erase the my work over here. Remember, I'm not presenting this to someone except in a video, but in my notes in the blue area, you'll see answers. Let me erase it over here. We've done 3. We did good. And now we're going to do another one. And so what are you going to do now? Well, I'll be honest with you. I'm going to do one that I find easy. I always look for low-hanging fruit. So I'm going to say number 1 looks easy to me. It's a factorial problem. I'll write this over here. And this is going to be n times n minus 1 factorial minus n minus 1 factorial. You may wonder why I did that. I want to factor it. And the bottom is going to be n plus 1 times n minus 1 factorial minus 2 n minus 1 factorial. Well, I'm going to factor out an n minus 1 factorial on top and on bottom. And on top, what do you get? N minus 1. What do you get on bottom? N minus 1 factorial. And then you're going to get n squared plus n, and I'm getting that from here, minus 2. Well, what's nice, these will cancel off, and let's keep moving forward. As I'm moving forward, I'll factor. The top is n, whoops, let me go back to black ink, sorry about that. N minus 1, and the bottom, I'm looking at this, yeah, it's written funny way, but I still can factor it. N minus 1, n plus 2. That would give me n squared. 2 minus 1 is 1n. And yeah, you get minus 2. This cancels off. What am I left off with? 1 over n plus 2. Simplified nicely. Again, like always, I'm going to look at the answer key. I want to make sure I'm getting that over there. Now, by the way, I think probably I didn't read the whole question, which is going to happen to you on exams. You're not going to read it. You're just going to you're so nervous, you're not going to read. But they said, are there any values of n for which this is not defined? And I want to put down, if they're asking that, probably an important question. So when would it be undefined? When the bottom is 0. All right, when the bottom is 0. Let's put this down for you. So when does n, whoops, sorry about that. When does n plus 1 factorial minus 2 n minus 1 factorial equals 0? Well, I already factored it before. I'm going to do it again. And what do you get? N minus 1 factorial. And on bottom, what do you get? You get n minus 1, n plus 2. We did that before, by the way. And when does that equal 0? Well, when n equals 1 and when n equals minus 2. So I'm going to say, are there any values for which it's not defined at these 2 values? And again, maybe I didn't read, I didn't read it, but I'll go back over here. And they said natural numbers except the number 1. Oh, I wrote another wrong answer down. Another good point. And I'll tell you why. Factorials, we don't have minus 2 in our factorial. So it's going to be n can't be 1. All right, sorry about that. So again, the factorials are the natural numbers, and they're removing 1 from the set. All right, so that would have been a penalty on a competitive exam, thinking it's an easy thing, low-hanging fruit. And I wrote something down without thinking about it. It happens. That's a good thing. So we did number 1. I think I did number 3. And I'm going to do number 5 now. I think it looks pretty easy to do. And again, when I draw a picture, I'm not saying it's great, but they said determine by graphical method the number of real solutions over here. So what I want to do is I want to kind of graph out one thing at a time. And I'm going to graph out y equals, let's see, the sine of pi x. Well, that's fairly simple. I want to point out what I mean by that. It looks sort of like this over here. I know it tops out at 1 and bottoms out at minus 1. And what's the length of that period? It's 2. So So this thing keeps repeating itself every 2 units. So 2, 4, 6, 8, 10. So I get, yeah, I'm not saying I'm doing a great job drawing this in, but sort of, it's really kind of crappy looking. I know that. All right. The next thing I want to do is I want to graph out y equals log base 10 of x. What about that thing, and this is the number 1 over here. I know this thing kind of shoots up here, hits this, and then someone says, I wonder what happens. And some people unfortunately do this over here. That would be incorrect though. And I'll tell you why. The scale might look funny to you, but this rises rather slowly. And it doesn't hit 1 until we hit 10. So at x equals 10, the y would equal 1. So I'm going to say this is when it hits the number 1. And then after that, it's going to be, so it's above 1 here, above 1. And in this side here, it's below 1. So I'm going to kind of count it up. And so if I was going to do that, 1, 2, 3, 4, but I would hit here too. So I'll put it in red. It's here once, twice, 3, 4, 5, 6, 7, 8, 9. It hit it 9 times, by the way. Now someone says, I don't really think you drew a great picture in like that. It's kind of hard for me to do that. I mean, I'm not a great scale, but I did a graphic, just not the best looking graphic in the world. So what am I going to say? 9 times. All right? All right, let's take a look. Let's see how we did. Who knows? Maybe I got that one wrong too. Well, I like their graph. It's much better. And I'll tell you why. Machine did it. Let me just count it up again. Hits it here. And then once I pass that 10, I want to blow this up for you. It doesn't hit it over there, right? You get the idea what I'm doing, right? So how many times? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, geez, 9 times. As they say, 9 times. So it's, again, I did a rough graphs. It's all needed to count 9 solutions of that problem over there. So that one's done. Not bad. All right, let's keep going. And I'm going to say that the other one's probably more challenging for me. So we did one, a little errand 1. 2 was fairly simple. 5 was fairly simple. And I got 2 left. Right, so I did 3. I got 2 left. I got 4 and I got 2. All right, so what I want to do is I want to go to the notes now in the blue area because I'm going to need a lot more room to do this problem over here. And, the first thing I would do is, they want to find, the zeros of f. And I'm going to say that's probably the easiest thing to do, all right? So I want to point out what I would do if I were doing this problem. I would write that down. I want to find the 0 of f. And what I did over here was I subtracted 1 from both sides. All right, then someone says, what would you do now? Well, I'm kind of looking at it, and I'm wondering what to do with it, but I kind of have to simplify it, right? And so it's just, how would you do that? There's many ways to do it. So, you're looking at what I'm doing, you're looking at what you're doing. We'll agree with ourselves in the end, but I'm kind of looking at this, and let me take a look and see what I want to do here. And it looks like I did something pretty interesting over here, which you may not realize what I did, but looking at it might give you kind of, reason to pause. What did that guy just do? And look like what I did, and I want to point out to you, I'm looking at these 2 sides here. I'm looking at this side, I'm looking at this side, and I'm trying to make it easier on me. And what I did was I took the reciprocal of each side. So what's the reciprocal of -1? It would be -1. And what's the reciprocal of the other side? It couldn't get easier. What's it going to be? It's going to be 2 minus, I'll write this over here for you, 1 over 3, I'm trying to reciprocal down, plus 1 over 4 minus 1 over x. All right? Again, reciprocal. I'm taking a reciprocal of this fraction here. So this goes on top, and the 1 goes on the bottom. All right? So I'm going to say that looks pretty simple to do, right? And then what I'm going to do, I'm going to subtract 2 from both sides and then multiply both sides by -1. And what would you get? You would get 3 equals 1, 3 plus 1 over 4, 1 minus x. Well, that's not so bad, right? So what I got to do now, I'm going to do reciprocals again because it works so nicely. So what I get? I would get 1/3 equals, I'm taking reciprocal of this side and of this side. And the reciprocal of this side over here is really simple. It's 3 plus 1 over 4 minus 1 over x. I'm going to subtract 3 from both sides. That's going to give you -8/3 is equal to 1 over 4 minus 1 over x. Now what I'm going to do, I'm going to take the reciprocal of both sides again. So you can get -3/8 is equal to 4 minus 1 over x. Now what I'm going to do, I'm actually going to subtract 4 from both sides. You know what? Let's try something different. Let's multiply both sides by 8x. The LCD is 8x, by the way. And what do you get? You would get -3x. Just hope we don't make any mistakes now, right? So let's see, -3x, because 8 cancels. Then you get 32x minus 8. Well, let's take a look at this now. What are you going to get? 35x equals 8, or x equals 8/35. All right? I think that reciprocal business is a pretty good idea. All right? These are continued fractions, by the way, finite continued fractions. So let's take a look. And let me just make sure I answered that question. Fine. Let me go back to the question, right? Identify the zeros. Well, I did that. Let me point out what I mean by that. This is number 2, right? So I identified the zeros by setting it equal to 0. What was the other question now? Ooh, the maximal real domain. That's tougher. At least I think so. So what I got to do is I got to worry about division by 0. All right? So what I'm going to claim over here is kind of looking at the original problem. X can't be 0, right? That's right from the get-go. All right? So I'm looking at that. The only thing I'm going to say is that x can't be 0, but 4 minus 1 over x can't be 0 either. All right? What does this mean? 4 can't be 1 over x, so x can't be a quarter. All right? I'm going to start to erase things. I'm done with this. What else do I know? And let me write this over here for you. I know that, whoops, I didn't mean to blow it up that much. I also know that 3 plus 1 over 4 minus 1 over x can't be 0. All right? Now I'm going to write that a little differently. I'm going to write 1, 4 minus 1 over x, by the way, can't be minus 3. All right? And now what do I know? I know 4 minus 1 over x cannot be equal to minus 1/3. I know that much. And what do I get over here? Well, I get 4 plus 1/3, and that's what 1 over x can't be. That's going to be 13/3, right? That's 12. Yeah, 13/3, 1 over x. Can't be 1 over x. So x can't be 3/13. I got to get my eraser out. It's a lot of work, though, isn't it? And, the problem with erasing is if I make a mistake, I probably won't know I made a mistake or where I made a mistake. Erase all this stuff. We did that, right? So we can get rid of that. Oh, boy. Oh, I got another problem on my hand. And what do I have over here? I'll write it down for you. So 2 can't be equal to 1 over 3 plus 1, 4 minus 1 over x. Well, I think we've seen this before. 1/2 can't be. Let's write this down now. Whoops, I didn't mean to do that. Sorry about that. Doing reciprocals again, right? I'll take 3 from both sides. That's going to be minus 5/2 now. Hope I'm not doing things twice, right? So let's see, that's going to be minus 2/5. I'm doing reciprocals again because they work so nicely. That'll be 4 minus 1 over x. And now I'm going to subtract 4 from both sides. That's going to be minus 22 fifths minus 1 over x. So that means x cannot be 5 over 22. Let's write that one down. I'm going to get my eraser out. And again, I always say, if I make a mistake, this is awful. So erasing my work and making mistakes is just awful. And 5 over 22. I got this last thing to do, right? I'm going to say, 1. I should say minus 1. And this over here, it's tough though, isn't it? A lot of writing. Reciprocals. Oh boy, got to deep under minus 3. Oh boy, I got to do more work, don't I? And did I do that okay? Yeah, so I'm going to put down 1/3. I know I'm going a little quicker than I expected to. Can't be 3 plus 1 over 4 minus 1 over x. Got to keep going, don't I? Got to take 3 from both sides, and that would be minus 8/3. Can't be 1 over 4 minus 1 over x. Oh, reciprocals again to the rescue. Minus 3/8 equals 4 minus 1 over x. Not equal, I'm sorry. And I'm going to multiply both sides by 8x. And what do you get? Minus 3x can't be 32x minus 8. Did I make a mistake somewhere? Let's look at my key. X can't be 0. 5/22. 3/13. Whoops. 1/4. And what happened here? I think I was solving the equation last but not least, but let me I got to check this now, because I'm coming up with this over here, and I'm wondering what I just do. So this would be 35x equals 8, and I'm saying x can't equal 8/35. Maybe I lost track of what I was doing. Oh no. No. I'm sorry, I made a mistake there. I was solving the equation for 0, and I don't know why I did that over there. But we did okay. I did way too much work on that one, all right? I was solving for 0. Sorry about that. I was doing the thing that they asked me to do originally. That was not a problem. That was not a 0 divisor. Sorry about that. Just going back to the original question. All right, confusing is not easy problems. I realize a lot of times people make mistakes, myself included. So let's take a look at the ones we haven't done yet. And I think I haven't done this guy over here. All right. Now, for a lot of students, word problems are the worst thing they have to deal with. So it's the freighter sailing due north. Let me draw a little picture of this. This is north. This is south. This is east. And this is west. So a freighter sailing due north, 12 miles per hour, sights a cruiser straight ahead and speeding due east. All right? So these guys heading north, but he notices that somebody else that's due, let's say, a freighter sailing due north, 12 miles per hour, sights a cruiser straight ahead and speeding due east at an unknown speed. So this guy's going in that direction there. All right? Okay, let's keep reading it. I got an idea what's happening over here. Freighter, moving north at 12 miles per hour, right? Sights a cruiser straight ahead and speeding due east at an unknown speed. After 15 minutes, the vessels are 10 miles apart. So I'm kind of seeing that, my understanding this is sort of like a right triangle problem. This is the freighter, and this is the cruiser. So a freighter, right, he's going north at 12 miles per hour, and a cruiser straight ahead of him and speeding due east at an unknown speed. After 15 minutes, the vessels are 10 miles apart. This is at let's see, at 15 minutes, the vessels are 10 miles apart. So this is at 15 minutes. All right? And then it says 15 minutes later, they're 13 miles apart. Well, I'm still going to do the triangle. It doesn't matter if it's above it or below it. They're 15 miles apart. Cruiser and freighter. And this is at 30 minutes now. All right? So after 15 minutes, the vessels are 10 miles apart. And 15 minutes later, which means 30 minutes later, they're 13 miles apart. Oh, I put 15 down. I'm sorry about that. All right? How far apart are the vessels when the cruiser is due east of the freighter? Okay, so that's going to be that 0 mark there. All right, how far apart are the vessels when the cruiser is due east of the freighter? That means they're on the same line. Okay, so let's kind of mark this down now, and find out what's happening here. And I'm gonna talk about. Let me see if I can do something here. And they say, I want to make sure he's going 12 miles an hour, right? All right, let's see if we can do that. And I'm going to start drawing like triangles down here now. So when he first spots them, they're there. Now, let me take the freighter sails due north at 12 miles per hour. And after 15 minutes, I'm going to call this distance, let's see, 15 minutes. After 15 minutes, vessels are, let me see, freighter sailing due north 12 miles per hour, sights a cruiser straight ahead and speeding due east at an unknown speed. After 15 minutes, let me call the unknown speed x. That's of the cruiser, by the way. So let's take a look here, right? So freighter sailing due north, 12 miles per hour, sights a cruiser ahead, speeding due east at non-speed. After 15 minutes, the vessels are 10 miles apart. So I'm gonna say over here, in 15 minutes, this guy's closing in on him, right? And this guy's over here somewhere. And the distance here is 10. And what's this guy's distance? Well, it's at 15 minutes, right? So that's a quarter of an hour, isn't it? So I'm going to say 1/4 x. All right? And then this distance over here is going to be what? Well, he's going how fast? He's going at 12 miles per hour. And so in 15 minutes at 12 miles per hour, right, that would be a quarter times 12, which would be 3 miles. All right? And I'm going to call this thing over here, the total distance over here, just d. And this is going to be d minus 3 now. All right? Now that's Pythagorean's theorem. I'm going to start to erase all the other stuff I don't need anymore. I don't need this diagram anymore. And let me just write down what I'm seeing over here. So what do I got? I got d minus 3 squared plus x over 4 squared. Let me get rid of this thing here. Is equal to 10 squared, which is 100. I want to point out where this is. This is right over here. All right, now let's do the 30-minute mark. Right, so the 30-minute mark, what happens in the 30-minute mark is, this is going to be further, right? So let's write that down. Let me just push this over here. So at the 30-minute mark, we got something like this. So it's going to be 1/2 of an x. And now the distance is going to be 13. And what happens at 30 minutes? Well, it's going to be, this distance here at 30 minutes is going to be 6 miles. So this is going to be d minus 6. All right? So Pythagorean theorem again. All right? So it's going to be this side squared plus this side squared. This is a right triangle, by the way. It's equal to 13 squared. This is assuming the earth is flat, by the way. For small distances, it certainly works out fine. All right, so we got those relationships over there. And, you know, I'm going to say, not that I want to go through all the work for you, but, you know, I'm going to say you really need to simplify these problems over here. So I got 2 equations now with 2 unknowns. All right, I got 2 equations with 2 unknowns. So what I want to do is, I'm going to erase everything else because it's all I really need now. I'm going to start to erase all my little tiny pictures over here. And I got these 2 equations with 2 unknowns in them now. And remember, x is the rate that the cruiser's going, and d is the distance initially between the cruiser, when he first spots the cruiser and the freighter. So I'm going to do some work over here for you. And it looks kind of complicated, but I'll write it down for you. It's going to be d squared. Let's see. I'm sorry, maybe I shouldn't do that. Let me erase this over here. I did it again, didn't I? Get my eraser out. Let's just do something over here. So d minus, I didn't erase it again. D minus 3 squared. I'm going to multiply both sides by 16. I'm doing this equation here. Plus x squared is equal to 100 times 16. I'm going to multiply the other side, I'm sorry, the other equation, this one up here, by 4. So I get 4d minus 6 squared plus x squared equals, well, 13 squared is 169, right? So I'm going to put down 169 times 4. Now I realize what someone said, what are you going to do now? I'm going to try to figure out what x is, or what d is. And I'm looking, what might be easiest for me to do? I'm going to say just subtracting them. All right, let me see if I can do that. So 16 d minus 3 squared minus 4 d minus 6 squared equals, you know, maybe I should do the arithmetic over there, and that's 1600. And 4 times 169, right? Well, 4 times 9 is 36. And 4 times 6 is 24. That's 27. And I get 676. And what's that going to give me? 676 from 1600 is going to give me 934. All right, I got a lot of work to do, don't I? And so I write this down, 16 d squared minus 6d plus 9 minus 4d squared. Let's see, that's going to be what? Minus 12d plus 36 equals 934. Now remember, if you're on a competitive exam, you know, and certainly there's not the greatest competition in the world, they're going to be looking at your work to try to sift through who's the best, you know, able to answer this question over here. But yeah, we're kind of running out of time, by the way. Let's put this down, 16d squared. And let's see, 16 times 6, 60 and 36, 96. And 9 times 16 is 90, 144. Minus 4d squared plus 48d minus, well, 4 times 36, right? That's 120 and 24, 144 equals 934. And let's take a look. I'm seeing this. That's 12d squared minus 48. And then you're going to get the 144 minus 934. I think I might have been mistaken the arithmetic somewhere. Let me take a look. I got to keep going. I'm going to divide by 2. 6d squared minus 24d. You may wonder what I'm doing, so I'm trying to make the numbers smaller. And that would be 450 and 17. 917. That's going to be 467. Let me see if I'm getting those numbers up here. No, I think I made a mistake somewhere. I see it, 924. I see it right now. It's nice to see your errors, though, I'll tell you. Oh, boy, let's take a look. 924 divided by 2 is 450 and 12. 462. Sorry about that. Let's see. I think I can divide by 6 now. D squared minus 4d. And 6 goes into 462. Let's see. 5, 6, 7, 42. 42, 77. and you get D, 7, and 11. Let's see, I'd say minus 11 plus 7. So D equals, what does D equal? Minus 7 or D equals 11? Now, I hope you realize that D can't be minus 7. Like D is 11. So what are you going to do with that? And, you know, I got to be honest with you, I got to go back and read the question. And it says, how far apart are the vessels when the cruiser is due east of the freighter? Well, you know what? I got to find out what X is now. Right? And what is X going to be? And yeah, someone says, well, if D is 11, could you figure out X? I think so. And what I'm going to do is I'll do it in what I consider the easiest equation to do it in. And someone says, do you need to do this? Yeah, I kind of need to do it. And just take a look at this. Actually, I don't need to do it, but I want to do it. And so I'm going to say if D is 11, 11 minus 3 is going to be 8. That's 64 plus X squared over 4 equals 100. That's not so bad, right? And I'm trying to figure out what X is, by the way. And I'm going to take 64 from both sides, so I get X squared over 4 is 36. And X squared would equal 144, so X is 12. All right? So yeah, someone says, what's the question? And I'll read it to you. How far apart are the vessels when the cruiser is due east of the freighter? So let's see. So let's figure out the time, first of all, how long it took to get this to happen. And remember that the D is 11, and that means 11 miles. And the rate of this guy going this D distance is 12 miles an hour. And he's going for a certain amount of time. How much time? Well, it would be 11 over 12 hours. And the other guy is going 12 miles per hour. So it's going to be 11 twelfths, that's the number of hours, times 12 miles per hour. And that would give me the distance of the cruiser. And that's going to be 11, so it's 11 miles. Wow, that was a tough one. And so, did I make a mistake somewhere? I think I did. Either in my notes or in my work over here. Let's see, D, the distance is 11. I got that part. Isn't this funny? Value X is 24 miles per hour. Let's see where I went wrong over there. So 11 minus 3 is 8, 64. I got that. That's 100. I see it now. It's 16. I'm sorry, 16. And then you're going to get 1,600. Let's write this down. So 64, I'm sorry, X squared over 16 is equal to 36. Take the square root of both sides. You get X equals 4 times 6, which is 24. Yeah, I made a mistake. This is 24. So the X is 24. And 24 times this is going to be 22 miles. Again, did a lot of mistakes today. No doubt about it. All right, but we got it. Tough reading. It's a tough problem. I realize that. It's a good problem, though. So remember this. When you're doing a competitive exam, try to tackle those problems you can do. Mistakes are going to happen, though. No one gets, I shouldn't say no one. Very few people get perfect scores, by the way. Look for the low-hanging fruit. Grab it. Go with it. Don't waste your time with things that are taking a long time. But if you have the time in the end, start to attack those higher hanging fruit, all right? And try to do as much as you possibly can. Thank you so much for paying attention.